Now the question is, how do we find out the MAC address of a device if we do know its IP address? This is performed using ARP, short for Address Resolution Protocol. Each node with an IP address, whether it's a host or a router, has a table to map between the IP and MAC addresses. This table is called ARP table. The ARP table keeps IP address, its associated MAC address, and the time to live for this translation. The TTL, or time to live, is the time after which the address mapping will be forgotten. Its typical value is 20 minutes, but it could be changed. TTL is used because the IP address might not be valid after a certain time. This might be because of a host move and assignment of its IP address to a new device. Let's explore an example of using ARP protocol while performing a transmit between nodes within the same LAN. For example, in the same figure we saw before, if A wants to send a datagram to B, but it does not have B's MAC address. This means its ARP table does not have an entry for IP address of B. Therefore, A needs to find B's MAC address using B's IP address. This should be done using ARP protocol. For this purpose, A broadcasts an ARP query packet to the whole LAN. This request contains the IP address for B as the requested translation. The destination MAC address for this frame is a MAC address with all Fs, which is a MAC broadcast address. Broadcast means that all nodes on the LAN receive that ARP query. B, which is the target node, also receives this ARP request. B will be the only node responding to this request. It will respond using a unicast frame address to A, using A's MAC address from the request frame, containing node B's MAC address as the response. Node A receives this response from node B and caches the IP to MAC address translation in its ARP table. This is saved until the information becomes old at the expiration of the time to live. The timeout, which happens at the expiration of the time to live value, would not trigger another ARP request. Instead, the timeout would cause the entry to disappear from the ARP table, and if node A later requires this translation again for another communication, it can use the ARP protocol to receive node B's MAC address again. ARP is plug and play. This means that nodes create their ARP tables without intervention from the network administrator. They instead build their own tables using ARP requests when they require the addresses.